Welcome everybody. Welcome to the second session of with LLPA and Microsoft. Today we're going to be talking about modern research data engineering in the cloud, how we manage our data and work with it and get real results out of our data. So without further ado, I'm going to pass over to Mario. Mario.
Thank you very much, Carl. So just for a start, maybe for you who haven't been on the last session, this is the session 2. I'm going to just quickly reintroduce myself again. My name is Mario Pilja, coming from Croatia, Zagreb capital. My background is more than 16 years in IT, started as a full stack developer, solution architect, project manager, etc., etc., etc. Why I'm here today with you, because I'm among the other certificates that I have from Microsoft, a Microsoft certified trainer. So I'm specialized of using Microsoft technologies in accomplishing lots of the business cases, lots of the custom software development over these 16 years. And my current focus is AI engineering, solution architecture, cloud. We are going to talk about the cloud technologies, especially at Microsoft Fabric, that we are going to continue, that we started from the last session, and obviously in consulting and lecturing. So feel free to reach me on the LinkedIn and ask any more questions that you have. So going further, let's just recap session 1, what we did 2 days ago. In 2 hours, there was a lot of information, lots of the stuff covered. We generally started with some kind of motivation about the research data problem. We mentioned some of the organizations across the Europe that are struggling with lots of different kinds of obstacles in their everyday job and everyday activities. We introduce cloud infrastructure as something that is not new, but something that is helping organizations across the world, not just from the perspective of the researching, but from the business perspective. And we started in exploring of Microsoft Fabric as one of the products from Microsoft in the Azure cloud, Microsoft Cloud. We covered the OneLake as unified data foundation, as some kind of big bucket where all of our different kinds of data can be structured, grouped. Mentioned Lakehouse, Medallion architecture, introduced some of the hierarchies and some of the organization structures in a Fabric, like workspaces for research groups. And we started to just scratch over of AI and governance in terms of introducing the data agent, what was some kind of, I would say, big thing and some kind of standard thing today, that we have ability to do natural language queries over our data to, let's say, talks with our data. Or that every single answer is auditable SQL query. We mentioned purview, lineage, what is, sensitivity labels, GDPR, AI Act. All those stuff was covered on a session 1. So moving forward to today's roadmap, we are going to go in a more advanced stuff. We are going to go in data ingestion, do introduction of research pipelines, have a few sentences about how we can cover unstructured content and why is this important, and how can we leverage from today's technologies like LLM. We saw in the last session that LLMs are helping us to query data by natural language. But today we're going to check how LLMs and some kind of built-in services in Azure on top of the Fabric can help us to understand some kind of data from the PDFs, for instance, images, audio records, or whatever. We are going to talk about real-time data, how we can inspect it, And we are going to just cover and wrap it up in architecture overview and briefly closing. So let's start. We already mentioned and talked about some kind of researchers' pain points. Today's focus is going to be how to automate some kind of data preparation. In general, there's a lot of researcher articles covering these pain points where researchers are spending up to 80% of time of cleaning data, where we have reproducible pipelines, no record of which transformations in what order, which parameters. We cannot share our work, those pipelines across the teams, across institutions or whatever. Siloed formats, PDF spreadsheets, sensor data, and separate systems with no unified catalog, which gives us friction in sharing our knowledge, in sharing our work. Unstructured data bottleneck from lab reports, field notes, ethic documents trapped in a PDF format. So we are going to try to answer on the question how we can leverage from technology like Microsoft Fabric that can speed up and tie up this kind of mess around here. Okay, so let's talk about data ingestion patterns. Idea is to get research data into platform without emailing spreadsheets, without all this friction that we already mentioned in a previous session. Current reality email attachments, CSV between institutions, we talked about in last session, no version of tracking, manual downloads, portal clicking, export, rename, uploads, share the drives, API frustration, some kind of custom scripts per source, breaking good formats, changes, etc., etc., etc. We want to move from this situation. We want to have a system that can even schedule automated ingestion from any different source. We want to have some kind of visual transformation as reproducible recorded steps. So by doing some kind of pipes, doing some kind of drag and drops, doing some kind of leveraging from the tooling that can help us to understand all this ETL process on a more intuitive way. Central catalog with full provenance for every single data set, cross-institutional access without data duplication, no redundancy, version controlling, and everything around it. Let's dig deeper into something that is called data factory. So this is the orchestration layer, for ingestion and orchestration. So this is the ingestion orchestration hub in Data Fabric. This is, you remember the pillars and the verticals and the toolings above the one lake and all data that is in our Data Fabric. So Data Factory is combined of the multiple tools. One of the tools is Dataflow Gen2 that we are going to show in a session today in a demo. We have two core tools, Dataflow Gen, and we have pipelines. So through the Dataflow Gen, we have visual transformation of the data. So we can attach to some different kinds of data sources. We can clean up the data. We can transform the data. We can merge the data from those data sources, which is really important stuff. And we can then afterwards in a pipeline automate this in a really complex, long or multiple different kinds of pipelines. So Dataflow uses Power Query online. It's visual no-code ETL tool. For you who are dealing with Excel, you're probably familiar with a Power Query. Behind the Power Query, there is a programming language called M. So you can script this thing, or you can just leverage from the UI tooling around it. We will talk about it in details. Pipelines, on the other hand, are here to schedule and sequence those kind of activities that are written in a Dataflow Gen. So we are then just doing some kind of logic workflows around it. If then go in this line, and if not, go in this line, do this in a loop, etc., etc., etc. Error handling, we're going to show it. So for key takeaway for you guys here is that this is your automated lab assistant that fetches, cleans, and files data on schedule. So you can reschedule it. You can put it to be, I don't know, every single day at 3 a.m. in the night. So all new fresh data ends up for you prepared. So you can then continue your research with fresh data, etc. So this is just one of the examples. Okay. On the right side, you can see some kind of glimpse, some kind of screenshot, how this thing looks like. It's a low-code graphical environment. ETL solutions, once again, to remind you what ETL stands for: extract, transform, load. It extracts data, multiple sources, transform it, load it into destinations, runs data flows. So we're going to now explore this data flow, the interface in more details. So on the right side, you can see screenshot with multiple different kinds of layers, multiple different kinds of points where we are, what we are going to describe right now. You have some kind of ribbon where you have option to set up different kinds of transformation commands like filter data, merge data, pivot data, split, change data types. You can imagine, for instance, when you want to import some kind of CSV file that can be pretty messy, you want to make sure that there's one column that is date, that is really date. You can change the format here. So the pipeline is then automatically check if there is some kind of data not in correct format, and it's going to throw you error on certain rows if this thing is not good for you. You have queries pane. You can list all data sources in intermediate queries in Dataflow. You have diagram view, some kind of visual flow showing how queries connect and transform data. Data preview, which gives you live preview of the data after each transformation step. So you can click navigate through it. So this is not, why is this important? Because this is not black box. This is not something that you will just turn on to be seated on your data and to have some kind of output. You have completely visibility, transparency over every single step, what is happening with your data, and you will have possibility to intervene with that. Click around it, you can do some kind of extra steps in terms of the data cleaning, transformation, merging, or whatever you like to do. And query settings, applied steps for every action recorded, and data destination config. In terms of data destination, you can imagine on the start, you have some kind of input data sources, and obviously you don't want just that this data stays here. You want to, after this transformation, do this final step. This is load, and you can set up data destination where this data should end up. This can be in some kind of temporary table in a lakehouse, maybe in a blob storage, maybe on some kind of other data source, whatever you like to do. It's when you're constructing data flows, you have lots of options for you to take care of. Some kind of pros and cons, benefits, limitations. Benefits, this is self-service. Researchers can build their own transformations without any kind of IT help. Performance, extract data once, you can reuse across multiple analysis and teams, just reshared the outcome of it. Consistency, same cleaning rules applied every time, eliminating manual variation. So once when you set up this, once when you save this, every single time, these rules will be applied on the data source. Limitations, on the other hand, you don't have full data warehouse replacement here. This is designed for ETL, not complex analytics. But in general, this is not, I would not say the limitation. This is just by design. This is the ETL tool. You will not store data by this. This is just some kind of, in a life cycle of data management, this is just one kind of step that needs to be handled from the source all the way to the destination. This requires Fabric capacity. Remember from the last session that capacity is nothing else but some kind of compute in a background, because every single stuff that you are doing needs to have some kind of compute instances, talking about CPUs, talking about some kind of memory, hard disks, or whatever. This is what is meant here by Fabric capacity, and you can scale it out, scale it down. You can, we mentioned last session that you as an institution have lots of benefits here. I will cover it on the end of our journey today as well and remind you about this. So you can see here some kind of benefits, limitations. Idea is to speed you up in this ETL process in general. Let's just think about common research ingestion scenarios. For instance, you have some kind of public data portals. You want to crawl data from this, from HTTP or CSV sources, daily, weekly, schedule it, maybe some kind of water quality monitoring. You can auto-detect, append new data in your data destination afterwards in one lake house or whatever you like to point it out. Maybe you want to query from the sources of institutional databases, any kind of relational databases, Postgres, Oracle, SQL Server, MySQL, whatever that means. It's secured connection via gateway. It's important stuff is that you just one remark here. Your data does not need to be in the cloud to be able to be accessed from the Fabric. You can set up something that is called gateway that sits up. This is some kind of, let's say, data pump that sits up in your environment, on-prem environment, and is giving you ability to Fabric to access this data, so you can do hybrid approaches of these constructions. Incremental extraction of latest. So you have lots of different kind of techniques here, which you can implement by talking of incremental load. Idea is to load only the data that is changed, not every time load every single data. It can speed up, obviously, the loading time and the quality in general. Example is hospital patient registry, only changes to upload. One more example here, instrument output. For instance, you have some kind of FTP drops, blob storage local files, and you want to drag them into one lake for further analysis and for further your research activities. Mass spectrometry, sequencers, parse headers, validate, load. Those are just some kind of examples what you can do around here. Moving forward to the pipelines. Pipeline is, you can think of the data flow as some kind of activity, of some kind of detailed task, what to do, but pipeline is giving you opportunity to move one step for, I would say, above it, and to orchestrate those kind of data flows. So pipeline defines sequence of activities that run in order or in parallel. So on the right side, you can see the example of one pipeline. Activities, there can be multiple activities. There are some kind of built-in activities. You can create your own activity. You can create this data flow activity, and you can just link them, and you can put them in a sequence or in parallel, or do some kind of logical decision when to go in one branch of activity, when to go in another branch. For instance, you have activities like copy data, run data flow, execute notebook, get metadata, send emails. Parameters, on the other hand, gives you opportunity not to have hard-coded this thing, but to have fine-tuned parameter values that can be passed at the runtime, which date range to process, for instance. Every pipeline run is logged. This is important stuff. By mean, success, error, warnings, everything is auditable. That's important for you because you can then inspect if your pipelines are correct. Some who is administrating this can inspect why did something broke, for what reason, maybe some kind of data schema on the data source changed or whatever. You have ability to inspect every single aspect of it. Start time, end time, status, row counts, error messages, everything. And pipeline is just automated experimental protocol. Each step is documented, each run is logged. That's key takeaway. Idea has been set to integrate some kind of data flow and the pipelines. Why? Because pipelines in general, has been said, can schedule some kind of data flows. Every single day at 3 a.m., start my pipeline. My pipeline is going to start the data flow activity that is going to fetch the data from the data source, transform it, load it, do some kind of data wrangling around it, and load it into the destination where we want to set it up. So you can do it on the right side. You can see common activities like copy data, incorporate data flow, add some kind of notebook to do some kind of additional stuff over the data, get metadata, execute some kind of script, stored procedure. So after data flow is complete, pipeline can run notebook for validation. You can schedule this, as been said, and you have completely some kind of ability to configure it and to schedule the config from frequency, start time, time zone, or whatever. If data flow fails, you can set it up to automatically try to retry. Maybe it was due to bad connection, due to connectivity lost to some kind of data source or whatever. You can skip it, send to notification. So you have really powerful tool here to navigate through the whole concept and the process of it, comparing to do this manually or whatever. Common activities, we're going to mention some of those. One of those is copy data. It's just a wizard, step-by-step interface to move data between sources and destinations. You have 100 plus connectors, depending on the different kinds of data sources, like Azure SQL, Postgres, Amazon S3 storage, Google Cloud, lots of different kinds of data sources. On the left panel, you can choose data source from samples and connect to your own systems. Right panel, you can configure destination, where, lakehouse, which table, which format, etc. So everything is some kind of, I would say, intuitive for you guys here. Mapping automatically maps source destination to columns. It's, I would say, intuitive. On one hand, you don't need to do it manually. You can just double check it, and you can just adjust if it's not mapped correctly, or you want to have some, or you have some kind of other idea what to do with the data, and just move with this. Pipelines can be really messy. Pipelines can be complex, I would say. So because of that, that's why you have predefined templates which you can reuse for your ingestion workloads and just adjust it. So those are pre-built templates which can be found in a Fabric for common data movement scenarios. Here are some kind of examples on the right side. Bulk copy from database, Gen2 to lakehouse table. Why do you want to use it? It saves time, just for you to be more efficient. So you can start work with a template, and you can just manually reconfigure stuff that you don't like from the template, or you have some kind of other idea, and you want to adjust it by somehow. It's useful for you guys who are maybe new to Fabric, because it's going to speed you up the learning curve about the platform, and it's going to show you already connected activities and already something that is working, I would say. We mentioned last time shortcuts. Shortcuts are giving us ability to connect to the data without copying it. By mean, you can think of it like a virtual pointers to external data, zero duplication, zero movement. So Fabric is taking care of querying this data live when it's necessary, and to fetch it, and to staging it, putting it in the memory so it can be available for you. Those are the supported shortcuts: Azure Data Lake, Amazon S3, Google Cloud Storage Dataverse. We mentioned last time different kinds of situations and the use cases here, like partner institution stores data in their Azure subscription, and you want to just, without giving some kind of extra complexity for the IT overhead, you want to just create a shortcut so the data can be accessed from your Fabric instance to exposed data in other Azure subscription. It's one logical view across consortium, no sync delays, no storage costs for copies. So that's the whole idea. And the data in general stays under original owner's access control and data permissions and everything around it. That's important stuff from the perspective of the governance, what we talked about last time. And you need to think that this is the cool stuff for you that can speed up exposing data and using data from external sources. Okay. Data provenance. I've been saying last time on lots of occasions that everything that you're doing in Fabric is audited. You have completely lots of the metadata is generated every time you do some kind of data wrangling, do some kind of administration or whatever. That's important stuff because you can leverage from this information. The platform is taking care of it. You don't need to do it manually by your own. Without it, you can have questions like, I think I downloaded this from last March. I might have filtered out some rows. So you have lots of potential question marks over your head. What happened in a history with the data and what did you do? So no record, no source URLs, versions, date, no log transformations applied. So maybe you cannot answer to the questions of the ethics board. How was this prepared? What kind of data did you use? How did you change the data, wrangle data or whatever? With this, you have answers to every single question. Every pipeline is logged, timestamp, status, row counts, every transformation step is recorded automatically. Every source version captured at ingestion. It gives us full lineage from raw file to lakehouse table, and you can easily just show it to the auditors, either it's ethics board or whatever that is auditing your piece of work. Okay, moving forward easily to our demo. Let's just remind ourselves to the previous session and our demo data set. We are going to connect the data which lives in a blob storage. Is one of the oldest the types of the resources in Azure. We prepared, if you recall last time, but I will repeat for the guys who are new in session 2. We repeat some kind of dummy CSV files that are sitting in a blob storage. And we will use Dataflow Gen2 to transform and load data into our lakehouse. That's the whole idea around it. Being said, we have some kind of European water quality CSV files. It's a raw data from 8 European sites, 7 institutions, 9 parameters, 508 records. We have this kind of validated CSV file with less records, summary CSV with 478 records, just some kind of dummy data for this presentation purposes. Okay, same data set from Monday. We are going to show how it got in a lakehouse in the first place. You remember in a session on Monday, sorry, on Tuesday, you remember that we just played around with the lakehouse, and now we're going to show how this data from the blob storage ended up here. just been mentioned again, recap from today's session, what we're going to use: Dataflow Gen2, visual no-code transformation, replacing manual cleanup, pipelines for automated orchestrations with scheduling, retry, error handling, full logging. We're going to copy data. We're going to do in a demo, we're going to stop there. But from data ingestion, key takeaways are those that you have data flow, pipelines, copy data, shortcuts, and provenance. This is all included as a tooling sets for you to play around with the data and to load it into Fabric. Let's move to the data, to the demo, Dataflow Gen2. Let me just quickly switch to my Fabric. Can you see my browser? All good? Yeah? I see Carl, thumbs up. Okay, all good. Okay. So you remember from the last session that this is our workspace prepared, where we have organized everything. We have different kinds of types of, I would say, objects. We've been playing around with a few of those last time, and we're going to cover every other today. So let's just jump to the Dataflow Gen2. So pipeline, we have ingest water quality data. Let's open our pipeline and let's check what's happening here. I have already opened. So this is a pipeline. It's not so complex. One, for the purpose of the demo, our pipeline is just having one data flow activity. On this pipeline, you can easily set up multiple more activities. You remember that we mentioned the copy data. You can have complex parallel activities, in sequence activities, etc., etc., etc. This is going to be executed, but let's check what is going to be executed for a start. Let's check. Let's bring back here. And let's open our data flow activity, so we can inspect what's happening. So the whole idea here is demo that we are going to replace manual download CSV, open Excel, clean columns, save to shared drive workflow. So we should definitely go into fully automated flow of doing this. I already did set up the connection to the source, which is on our blob storage. Our blob storage is here. We have multiple different kinds of CSV files. We showed it last time. So European water quality raw CSV. We can even inspect the content of it. So it's some kind of dummy CSV data. Okay, let's just jump, here. And once when we connect to the source, you can see here which kind of steps did we apply over here. We connected to the source. You can click on each kind of step to check what's happening. We fetched some kind of CSV file. We imported it. Behind every kind of step, you can see this thing that is called M language. If you're familiar with it, you can even write it down in an advanced editor. We see here that we had some kind of step that transformed the first row as a headers. And we have here the step that changed the types of the columns in the corresponding data types. And we can inspect, we have the sneak preview of this data. What's important here is that not just we set it up the source and did some kind of connection to it. Through these steps and through this kind of stuff that you can see here, where we have multiple stuff that can be set it up for in terms of transforming data, in terms of unpivoting, splitting, merging, or whatever. We set it up the data destination. What do we want to do with this? For our case, our data destination is our lakehouse. You can see here some kind of info about it. It's in our workspace. It's in our lakehouse called like this. We are matching this kind of table, and there's a different kinds of let's say the methods on which you can do the data load. You can insert the data fully. Maybe you want to delete in a lakehouse everything, and you want to load everything from the scratch. You want to update or whatever. We set it up the update method for a start. So it's important stuff here to remember that everything in this kind of steps, in applied steps, is going to happen once when we are here in our pipeline, where we added this kind of step. On our pipeline is where the work really happens. So this is visual, no code tool, no programming required. We just navigated through it. We checked everything around what is going to happen in a background. So just to be short and precise, this step is going to connect to the Azure storage, is going to pull the CSV file, it's going to do some kind of data wrangling around it, doing some kind of changing the types, doing some kind of understanding which kind of columns do we have, some kind of data mapping between source and destination, and it's going to do it completely automatically. You can validate the stuff. Okay. Sorry, can I ask you if you can just mute yourself, because I'm hearing myself. Thank you very much. Okay. And once when we are satisfied with our pipeline, we can just click run, and our pipeline is going to start. Here you can see the status of the pipeline. It's queued. The whole engine of the fabric is going to do on the compute resources in a background. It's going to run this. It's going to, you can see here which kind of activity name is currently in which kind of status. Again, I will repeat to you, this can be really complex. You can some kind of production ready pipelines have on tens, 20 of different kinds of activities, because you can imagine that data loading and transforming, it's not often so easy stuff and just straightforward thing to do. But here is the tool that can help you to do it as quickly as possible in general. Okay, we are running this. We are checking the progress of it. Okay, let's just give, you can see here the duration. It's automatically refreshing every 5 seconds, or you can just switch it off if you like. So in general, what we are seeing here is that we are replacing this manually. Download CSV, open Excel, or whatever tool that we are using, clean it manually, share drive workflow. We have same transformation every time, fully logged, full auditability. This is no code path. So field researcher with no programming experience can build this in the Power Query visual editor. You saw on my previous page how this thing is looking like. So for more complex transformation, you can use notebooks, and we will show it in a next demo in general. Okay, let's just wait a few more seconds so this activity can finish. Okay, we have success here. You can inspect this by checking the input, by checking the output. Output is just some kind of job in a background that gives us full some kind of traceability of the audits, etc. But important stuff is that our data flow has been a success. So that means that we transformed the data from source CSV into our lakehouse, which is a relational database set up for our purposes. Okay, let's just quickly recap this. Manual already said, after we have pipeline that can be scheduled, fetches automatically, visual transformations, data lands directly, full audit trail, and this is, I'd said, a dummy data example, but the idea is here, and on production-ready environments, terabytes of data can be transformed like this, and with different kinds of strategies. Moving forward, let's check some kind of research pipelines, reproducible analysis. We'll talk about notebooks. We played on a last session with just one glimpse of it. Apache Spark Digital Lab notebook. Why notebooks in general? Because it's some kind of natural habitat. In general, researchers are familiar with Jupyter notebooks, and those are the toolings that have been used locally or on whatever environments. Same knowledge can be applied here. Fabric notebooks are Jupyter-style environments running in the cloud. If you're familiar with Jupyter, Google Colab, or R Markdown, you can just use it with the same knowledge. It makes code cells, visualization output, narrative markdown text in one document. Been mentioned last time. You have multiple different kinds of languages supported: Python, Spark, SQL, Scala, R, and the key difference between local Jupyter and this is that this runs on managed cloud compute. What does it mean? I will repeat that once again. You don't need to think about the infrastructure in general. This can be several nodes that are combined in some kind of data center or linked multiple data centers across the Europe in a background. You don't care about it. You just want to do your job. You don't need to think about any kind of infrastructure. So in general, multiple researchers can access it and edit at the same notebook and collaborate on this, which brings us to this team collaboration. In a background, when you're dealing with the notebooks, Apache Spark is being provisioned for you automatically. So what is this? It's just core technology. It's distributed data processing framework through Spark tools. It's something that is used for big data, we like to say. From the data management perspective, it gives us some opportunity to do management with large-scale data analytics, process data across multiple machines. So this is everything that you see on the right side happens automatically. It's fully managed by Azure, talking about scaling out of the different clusters, nodes in the clusters. Clusters are auto-provisioned, been set, auto-scaled, auto-pause, no infrastructure to manage. Same Spark code works on 500 rows or 500 millions of rows of data. That's important stuff. You don't need to do any kind of changes in your code. The same approach works. Fabric takes care of any kind of infrastructure that is in a background. That's important stuff to remember. Okay, those Spark pools start on demand when you run notebook, as you will see in our next demo, and pause when idle to save the cost. So you don't need to think, oh, how much money this is going to cost, how much infrastructure did I just burn out or whatever. Everything is fully managed. Okay. When you're dealing with the notebooks, when you're dealing with Spark, you're dealing with some kind of Spark data frames. It's a table-like structure in the memory, rows, columns, spreadsheets. This is the knowledge, if you're done work with it, that you already can transfer here, that the schema can be inferred. You can specify schema more reliable. You can do any kind of stuff that you already know from your existing knowledge and your existing workflows, doing stuff not on Fabric. And you do everything through this Lakehouse Explorer, and which will show you the tables and files for browsing. Here in a Spark data frame, you can transform data, transformations, modify data frame, filter rows, data columns, aggregate, joins, every single stuff here. You can save transform data as Parquet file. We will not go right now in a depth of the meaning of it, but from you who are familiar with it, it's a really powerful and industry standard right now to deal with the big data. It's a column format, much faster, smaller than CSV for analytical queries. Spark jobs, you can set up different kinds of administrated those jobs. In general, transformations are lazy. Spark only executes when you trigger an action by main, show, write, or whatever. Above Spark, you can use Spark SQL, use Metastore to define tables and views, create external tables. Okay, so you have complete support around this programming language. You have Delta tables that support ACID transactions, versioning, time travel, rollback to earlier states. So once when you load the data here is the stuff where you can play around and to explore the data and do some kind of analysis, whatever you like to do with that data. On the other hand, just mentioned querying possibilities. You have two ways to query. Either you use PySpark or SQL. PySpark through the PySpark API, which is completely integrated in it. You don't need to think about what it is. It's under the hood with this kind of syntax. Or either we're talking about writing native SQL directly to cell, no Python wrap needed. Both are querying the same Lakehouse catalog, returning identical results. So key takeaway here is that you have multiple weapons by your choice, where you feel more comfortable to deal with. So in general, PySpark is better for chaining transformations programmatically in a pipeline. And the other is better for ad hoc explorations and research more field at home with SQL. Important stuff here is performance, because obviously you're not in your work, you're not dealing with some kind of dummy data that I have here in a demo that has 500 CSV with 500 rows. You are dealing with gigabytes, terabytes of data that needs to be wrangled, that needs to be analyzed, that needs to be merged, consumed in different kinds of ways, scenarios. You have opportunity here even to do some kind of performance optimizations by doing partitioning. What that it means? It's splitting large data set into folders by column values. Why? Because then you gain performance on querying such data. You obviously need to understand your problem. You need to understand the narrative of the data which you have. Then you can partition data by this kind of key. Maybe you want to examine data that is only on a year to 2020 or 2021, then this is the good partitioning key to split the data in it, so you can leverage the optimization and performance here. So query benefit in this case is where where clause where year 2021 reads only 2021 folder, skipping the other years. So you have reads only on the subset of the data. So that's it's all partitioning all about, physically just storing data in different kinds of partitions to speed up the whole process for you. Okay, let's talk about just one thing. Moving, I want to just give you some kind of mirroring and give you some kind of comparison between always local scripts and stuff that are organized in a fabric. So let's just mention on a case of the local scripts, you have cases like runs on my laptop. How many times did you hear works on my machine? I swear to God, it works on my machine. So you don't have any kind of records, which library versions you were used. Output is saved to somewhere on my desktop. Colleagues can reproduce. They have different kinds of Python, R version, environment settings, or whatever that means. Data is local copy that may be outdated. But on the other hand, with Fabric notebooks, you have managed cloud compute. It's standardized environment, has been said, completely managed by Azure. Library versions are tracked, reproducible. Output is saved to Lakehouse automatically. Colleagues can open those same books and do the work on them. And because of this, they will have the same result. Data from shared Lakehouse is always current. That's important stuff. And moving forward, I mentioned already last session, let's talk about MLflow. So what is the MLflow in general? So once the one job that you can do in a notebooks, obviously, is do some kind of this data wrangling, ETL processes, analysis of the data, querying of the data, but you want with that data do some kind of smart stuff. You want to do some kind of machine learning for start. MLflow gives you this. This is computational experiments in a lab notebook to bench some kind of experiments, to test some kind of hypothesis around it. You have different kinds of input settings, parameters. It's like recording reagent concentrations, metrics, output measurements. This is all supported by it. Artifacts, saved outputs. It's train model, some kind of charts, confusion metrics, all those stuff that are important for you from the perspective of the research, because this is where the smart thing is happening. You just moved the data, you cleaned it up, you did some kind of basic querying, but right now you want to do some kind of statistical analysis of it, to maybe train some kind of model, to maybe test some kind of outputs of the model. You can have support for support for this here. And obviously everything is audited, tags, notes, metadata from author, experiment, name, like your lab notebook header. Okay, let's just compare experiments run side by side as well. You can have multiple, like you will see in our example, we will do on the data which we loaded, multiple experiments, and MLflow will give us opportunity to side by side compare those experiments in general and to see success, to speed up our whole activities and our efforts. Run 1, maybe using random forest. On run 2, doing some kind of other algorithm. Run 3, third algorithm. You have comparison in a notebook via MLflow that will give you metrics, and you can decide in which way you want to continue your research. Every parameter combination is permanently recorded. You don't have, I think I tried that last month or whatever. Again, multiple cases here. You obviously will find out where this suits for you the best. Biomedical, compare classifiers across patient subgroups, tracking features, engineering, log models for regulatory submission. Environmental, maybe forecast across climate scenarios, compare new monitoring data arrives, log water quality prediction parameters. Social science, log NLP runs, next text classification, track sentiment parameters, compare embedding strategies. So you can think of different kinds of scenarios right now for your own. Moving forward to our next demo, where we are going to explore notebook diabetes biomarker analysis, which is already in our workspace prepared. We are going to use this kind of data set. Idea is to have quantitative measures of disease progression 1 year after baseline. We have different kinds of approaches how to do this, and we will compare those. MLflow will autolog, captures everything automatically, zero explicit logging code needed, and just watching this demo, automatic tracking, we do not write explicit any kind of logging. Experiments panel, we will check it. Comparison view, we will check it. Before moving to the next demo, all good with you guys? Do you have any kind of remarks, questions? So far, so good? Okay. Let me just then switch to my Fabric. And switch to our workspace. Okay, so as been said, we will move from data ingestion to analysis. I'm going to show you notebook environment. Most of you will find it familiar. It's essentially it's Jupyter integrated in a Fabric platform. Something important here, has been said, is automatic experiment tracking. Okay, so you can see here multiple objects. One of our objects is notebook. So let's open our notebook. We have it already over here opened. Okay, this is our notebook. So we have some kind of markdowns explaining what this notebook is all about. It demonstrates reproducible computational research using medical research data set. We are going to explore 2 predictive models compared side by side, and MLflow is going to track every single experiment run, parameters and metrics. Okay, so we are going to ask a question: can we predict diabetes progression from baseline patient measurements? And let's check it. So right now here, this first cell is going to load diabetes research data set and sets up the MLflow experiment tracking. So MLflow is going to be our digital lab notebook. It will automatically record everything we do. Okay, let us run this. You can see here progress, something is happening. You can see here activities, some kind of session started. Okay. We have time tracking. 18, 19 seconds. Okay. Let's wait for a few more seconds for, you remember that what we spoke about Apache, that Spark, that it's switching off when it's idle, not to spend any more money for you guys. So right now with our first query, we are warming up, and the Fabric is doing provisioning of our Apache Spark in the background. What happened, and here right now you can see, okay, a data set where we have some kind of logs. 442 patients, 11 variables. You can see the glimpse of it, and you can see completely a log of what happened in the background. That's important stuff for you. Okay. Moving forward, let's go to the second cell. Let's just, before modeling, let's, for instance, explore our data. This is standard practice. Let's, I don't know, check distributions, identify outliers, understanding the variables. Nothing here specific. We're just going to run this query. Is just going to give us some kind of rounding of the data. Here you can see here some kind of preview. And let's move to the next cell. What are we going to do here? We are going to use our data and we are going to train simple linear regression model. And let's just check what will happen next. Let's run this piece of the code right here. You can see the progress running. As been said, remember that you can write this code in any kind of language that suits you the best. We can check the live logs, what is happening right now in the background. Okay, so we have here run list. Okay, model was trained with MLflow, logged parameters, which algorithm, which features, metrics, R-squared, whatever, model artifact itself. So this is your record, reproducibility record. So anyone can see what exactly was done and replicate it. So the same thing we did already for second model decision tree, and obviously in a last cell we have comparison of experiments, and we can do it by certain metrics. And after that, on each kind of step, we can inspect different kinds of just a sec. We can inspect, for instance, let's go here, linear regression. We can check the run details. We can check the model. We can have a glimpse of the different kind of environments setting up in the background, our model, our conda setup, configuration, etc., 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 etc. So model comparison, you saw it. At the end, over here, you can see different kinds of runs, which was already did by me to speed up the things, but it can help you to do, helping you to do that. Model registration, you can save ML model. You can do this as some kind of version deployable artifact. You can then deploy it in Azure, which is not in the scope of our session today, but this model can then be with all those requirements and everything, it can be deployed as a container in some kind of Kubernetes or whatever infrastructure that is, and it can be reached, accessible from different kinds of applications or different kinds of workloads afterwards. So the important stuff here, all artifacts are portable. You can download this model file, yeah, deployed as API endpoint, loaded in another notebook. Conda and requirements mean anyone can rebuild exact Python environment you used. That's important stuff. And this scales. So being said multiple times, this is cloud in the background. This is fully managed by Azure, and this scales. This is not only about 500 rows. This can scale and give you opportunity to have really good infrastructure to wrangle with your data on the large scale. Said that, just to recap the demo, no explicit logging code. Each run is immutable. Comparison in seconds. It's shareable. You can share workspace with any kind of team member, and anyone which who you share to can see experiments, reproduce the analysis, participate on it with their own insights or whatever. Okay. Moving forward from this approach, let's talk about unstructured research content. By mean, we are talking about some kind of lab reports, field notes, documents. We're going to check how we can extract any kind of structure from unstructured. This is some kind of, again, motivation behind it. It's estimated that 80 to 90% of enterprise data is unstructured. When I mentioned those kind of different kinds of types of documents, obviously we are talking from the perspective of the IT management, different kinds of extensions of the files, PDFs, Word, scanned images, every PowerPoint presentations. We have lots of data locked in those kind of data formats. But this does not mean that they're lost. We will see right now how we can analyze and use this data as well. This is as well some kind of, I would not say fun fact, but it's a fact that postdoc spends 2 hours extracting 15 values from 20 lab reports every month with typos. In general, structured data lives in our lakehouse, what we want to do here, and unstructured data lives in filling cabinet. We want to reduce this gap. We want to unstructured data move in our lakehouse as well, so we can analyze it and we can get some kind of benefits from it. Okay, that's as well some kind of fact that 5-year multi-site study generates 10,000 plus lab reports with extractable data. So the whole concept here is how we can use today's technology, how we can use the LLMs and lots of different kinds of OCR models or different kinds of models, AI in general, to extract this data and to understand, not just extract, but to understand the content of it and to prepare it, to move it into Fabric for further research activities. Okay. Introducing here Azure Content Understanding. That's a separate service which can be used from the Fabric. It's a multimodal content extraction service which analyzes documents, images, audio, video. You are the one who are defining schema, specified field names, data types, descriptions, whatever you want to extract. AI extracts matching values from submitted content with confidence scores per field. And for each field, you have score. You have some kind of confidence that AI gets to you. By mean 90%, I'm sure that this data represents this business value or stuff like this. You are defining schema once, process one document, 10,000 documents, then with same accuracy. You have some kind of diagram on the right side, just showing what I just explained. Okay, content understanding portal shows the document with extracted field highlighted. We are going to check this portal in a few minutes. On the right panel, fields, you can see a list of fields, entities extracted with color-coded confidence percentage. Green, high confidence, blue, good, red, low, and this needs review. So every time when we are talking about AI, obviously we are talking about human in the loop. So we need to check what's happening over here. We need to be in a position of some kind of team lead, and we need to confirm that our team did a good job. Bounding regions shows where on the document each value was found. From the perspective of the research workflow, we can extract hundreds of documents, auto accept with high confidence, and not spend so much time in reviewing and all this, maybe even manual things to do. Not just documents, As been mentioned, we are not today. We have data stored even as a PowerPoint presentations, as a video, as a text, audio records, and image as well. We can extract data from charts, and not just extract, but I mean without understanding. AI can give us glimpse and summary. What did we extracted here? We can extract structured data from charts, photographs, infer values from bar charts, pie charts, line graphs, identify objects, text, spatial relationships in a photographs even. Why to use this? So we are using this to have some, maybe digesting some kind of legacy or research figures from scanned papers, historical reports, extracting data, title, summary, category names, percentage values, all as structured JSON. On the right side, you can see example of such process. Connecting unstructured to structured. Let's move forward. We already mentioned and showed how we can set it up the pipeline. So we can set it up the pipeline as well to consume some kind of PDF files, lab reports from different kinds of data sources. You saw that we can do it from either from some kind of on-prem solutions, Amazon cloud, Google cloud, whatever that is. We're going to set it up, use those PDFs. We're going to attach content understanding. Content understanding is going to extract the data from it, and it's going to extract it in some kind of JSON format. Why JSON format? Because we have done metadata of it. And this JSON can then be used in a fabric and can be then consumed, merged with some kind of different data sources, and gets us extra context for our research, maybe where we will do data wrangling, where we will do some kind of modeling afterwards, and do some kind of publishing of the articles, whatever we want to do afterwards. This is closing the loop. Unstructured documents are becoming structured with the lakehouse data automatically. By mean extracting fields, joining our validated measurement data that is already in our lakehouse for combined analysis. Batching processes hundreds of documents through the same schema and pipeline. We have quality control here, confidence thresholds that are ensuring high quality extractions enter the lakehouse. And this is exactly what we are going to show in our next demo. We are going to extract the data from some kind of dummy lab report. I will show you shortly this PDF file that is giving us some kind of synthetic water quality field report from some kind of station. We're going to extract data from it, and you should be just watch for schema definition, confidence scores per field, scale potential, etc. Do you guys any kind of questions before I move to the next demo?
No.
All good. Okay. Let me just then switch to my browser. Okay. Okay, for a start, let's inspect our source, data source, which is stored in an Azure Blob Storage. It's stored here. It's some kind of PDF file. Let me just download it so I can share it with you. It's some kind of dummy water quality assessment report. You have different kinds of data here: report ID, site, when it's issued, which kind of campaign, who, which institution, where, longitude, latitude, with some kind of executive summary, sampling methodology, and some kind of results. So the whole idea behind this is just for now, for current purposes, only one file. You can imagine that maybe we have on a source tens of thousands, millions of such files that needs to be that can gives us that can give us opportunity to extend the context of our research data and to broader our exploration further. So moving forward, let's move to the Content Understanding Studio. So Content Understanding Studio is the separate portal where you can try out pre-built analyzers, or you can set it up some of your own analyzer here. Let's just explore for a while this. Give me a sec. Okay, so this is you can from this portal you can extract structure field from unstructured documents. This is not, again, been said, part of Azure portal. This is separate portal. You can see here by link. And the whole narrative is that you can have here different kinds of types of the documents which you want to analyze. This is something that Microsoft already built up for us. OCR read converts printed handwritten text in a PDF. A layout which extracts tables, checkboxes, text layouts, etc., etc., etc. Document fields which extracts key value pairs from structured data from any kind of document, names, dates, and addresses. Procurement, US tax, for instance, form, ID document, contracts, credit cards. So you can imagine that those are predefined, some kind of templates, and with that you have as well opportunity to analyze call recordings to extract topic, sentiment, speaker roles, audio search as well. You can analyze your audio files to extract language, speakers, even sentiment, key topics, video search. You can extract transcripts, speaker information, scene changes. You can understand that in the background, we are talking about using of different kinds of AI models that can help us here, image search, etc., etc., etc. What are we going to do here? We are going to use pre-built analyzer that is going to examine the document that I just showed you and extract key value pair automatically. So this is just a glimpse. This is just a little showcase for now. So we are going to use our document fields. Let's open it. You have some kind of predefined example over here from Microsoft. On the left, this is the sample data. You will see, and this is something that we will have user experience as well when we upload our PDF file. Here, you have here rounded different kinds of types of data. On the right side, you have AI that has tried to guess what kind of data that is and extract the data. What's important over here is that we did not say to the whole, I would say, workflow that here we have invoice data. AI understood from the whole context of it, like we human can understand. This should be probably the invoice number, and you can see here some kind of confidence from it. Why is this good stuff? Why are we using this kind of portal? just to play around with it and just to inspect is our outputs are going to be in our expectations. So you can have here some kind of idea what is analyzed, and you can fine tune it, etc., etc., etc. Let's browse our PDF file. Here it is, and we are going to prepare for analysis. Right now, Portal is doing this in a background. How is he doing? It's doing it by using multiple different kinds of models that we provisioned in a background. I'm not going to go in architecture right now. This is something that is done out of the box, but just wanted to show you what is under the hood of it. Are multiple models, GPT-4o1, GPT-4o1 mini, and text embedding large. All this is used for processing our documents. So sorry, let us move here. All those models have been used so for us, so we can get following results. Okay, beautiful. All of those models have been really smart, and they're concluded that this is a report ID, this is some kind of site name, date issued, etc., 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 etc. So now you're thinking, okay, this is the manual work. Why do I need to do that? And what's the issue? What's the idea behind it? Behind it is this kind of result. Content analyzer generated this kind of JSON. And this kind of JSON has some kind of schema with the contents, and in some kind of broader picture, you can imagine that in a Fabric pipeline, you can set it up one activity that will iterate through the all different kinds of PDF files that are sitting in Azure Blob Storage, for instance, and it's going to analyze it and extract this kind of JSON. This JSON has a constant schema. You can easily then move this JSON by data transforming, loading, ETL process in a lakehouse, and then you can leverage from this data by using after queries. You can even build up some kind of models on top of it, and you can merge this data with the data that is already existing in our lakehouse. That's the cool part around it. So the AI did all this OCR, understanding of the document, all this rough work of this PDF file. We have opportunity to this portal see, not just by inspecting the JSON, but on example how this thing is done, what has been marked or whatever. And we are then confident that this is going to be in the same schema every single time, and we can then automate this in a Fabric pipeline for every single PDF afterwards that is going to come here. And we can then have benefits of using such data. Okay. So content understanding return structure JSON. Field names, values, confidence scores. Data factory pipeline can call this API via a web activity, process batch of documents from blob storage, write the extracted fields directly in a lakehouse table. Those PDFs become rows in a research database, queryable alongside instrument data, for instance. So this unstructured data becomes structured automatically. Remember from the beginning of our session today that you can pay pipeline schedule to do this every single day. Maybe you're expecting that every single day field technicians are going to upload the new PDFs on the end of the day, and maybe you're going to start the pipeline processing this data every day at, I don't know, 12 p.m. Okay. Maybe use case here for you is historical data rescue, digitalizing paper era records, extracting data from legacy instrument logs, processing batch submissions. Every single thing that cross your mind right now can be achieved with this. So recap here. Before, manual, postdoc reads each report by eye, type values into Excel or whatever that is. 2 hours, spends 2 hours for this. It's inconsistent with lots of issues. No audit trail of extraction, nothing. Right now, after attaching the content understanding API, we have AI that processes batches automatically, JSON with confidence scores per field, and we have full traceability, schema, threshold, time, everything. Okay. Before moving to real-time streaming research data, that is our last chapter for today. Do you have any questions? All good?
But yeah, no, absolutely. I was just looking at that, thinking this must be so useful for things like the legal profession, where they're looking at hundreds, thousands of documents, and they're trying to produce summaries of those, getting extracts from those, and so forth. And yeah, and the word Epstein came to mind here, where analysis of millions and millions and millions of documents would be amazingly useful for this kind of technology.
Yeah, for sure. Thanks, Carl. Okay, let's move to real-time streaming research data. Scenarios like continuous ingestion from sensors, instruments, environmental monitoring. Okay. What is real-time intelligence in general? That's a fabric experience for processing continuous data streams. So as been said on session 1, we are living in an IoT world. Everything around us is generating data. Tremendous amount of data is coming every single day. And the idea is that we want to have some kind of benefits from it. Event stream captures those data flows from sensors, IoT devices, streaming applications. Event house store streaming data in a time series, optimized format for fast queries. I mentioned the last time KQL. We are just going to spend a few minutes explaining the benefits of KQL. And real-time dashboards shows live updating visualizations, and real-time hub provides discovery. And you have everything that I just mentioned built in the fabric, and you can materialize the snapshots of the data for further analyzations, for business intelligence, do some kind of development of the models, everything in one place. Okay. So event stream is something, part of the fabric that captures continuous data flows in a real time, processing millions of events per second. Sources like Azure IoT Hub, Event Hub, custom applications, Apache Kafka, for instance, Amazon Kinesis. We are talking about different kinds of protocols here, obviously, since we are in a event streaming world. Destinations Event House for real-time queries, or Lakehouse for batch analysis with custom endpoints. You can apply flight in transformation for data lens. Why? You maybe want to filter out something. You want to aggregate on the fly, or do something like this from raw data that is coming in. Examples: ocean, telemetry, air quality sensors, network, clinical wearable accelerometers. You have lots of different kind of examples here. So on top of that, I already mentioned KQL. KQL is a querying language that is not strange to use in Azure environment. In general, what is this? This is read-only query language designed for fast exploration on large data sets. It discovers patterns, identifies anomalies, builds statistical models. You can do that by this. It's case sensitive, widely used across Azure, been said, log analytics, Microsoft Sentinel, Data Explorer, Fabric. So if we know SQL, KQL feels similar and use pipe-based syntax instead of nested clauses. Okay. KQL as well is part of Microsoft Fabric by KQL query set, dedicated to workforce item for writing and running KQL queries. It also supports TSQL queries in the same interface for SQL users. you can explain those commands that this is going to convert SQL to CAQL automatically. It's great for learning. And you can use both CAQL and TSQL in the same session. Why? For time series data, CAQL has advantages. It's built-in time windowing functions and anomaly detection. So you have those functions built in a language itself. Here is just a short glimpse how this CAQL looks like. You have pipe syntax, where clauses. It's similar, like some things are similar, like SQL select. You see here similarities, and you read top to bottom. Each line processes the result of everything above it. So this is why I said it's pipe syntax. Best practices for writing, filtering, apply. This is just one thing, optimization tips and tricks for it. We will not spend much time here, but idea is that you use this CAQL on a real-time data, and you can really benefit from the engine under the hood, which gives you lots of different features for creating this data. Research scenario, why we want to do that? Maybe we have 12 water quality sensors across Dutch waterways transmitting every 5 minutes. You can imagine how much data are we talking about here. In architecture, sensors, IoT hub, event stream, event house, lake house, real-time path from CAQL dashboards that are showing current values and giving you alerts when pH levels increases or decreases outside of the approved frame. Historical path lakehouse stores all readings for long-term trends analysis, so you can then do proper SQLs, Apache Sparks, notebooks, do some kind of training of the models, do some kind of analysis proper. Dual path real-time for operational monitoring, batch for research analysis. Both paths are sharing one lake. Remember from our first session that we had a foundation for everything. Every single data sits in a one bucket, and it's organized over there. One lake, one data foundation. And it's similar to national water monitoring infrastructure. When to use real-time, when to use batch. Real-time intelligence, obviously, when you have IoT case scenarios, continuous sensors data streams, sub-second latency needed, anomaly detection, alerting, experiment surveillance, dashboards. So you will use event stream plus event house plus CAQL. On the other hand, you will have batch ingestion on some kind of periodic data drops. Maybe you want to build up some kind of analysis and or dashboards on a daily, weekly, quarterly, half-year timeframes. Data from portals, databases, ETL, validations with quality checks, proper things, historical analysis, trend detection, and you will use Dataflow Gen2 and pipelines. So those are not separated things in general. Maybe you want to afterwards analyze the stuff that was once real time, that is then materialized in a one lake. You can do it in a batch ingestion afterwards. This was our final chapter. Let's now spend a few minutes just to wrap everything up, what we did in our two sessions. In 2 days, 2 days ago and today, to have complete picture and to have every single dot connected, end-to-end research data architecture from raw data to published results. So we are starting from different kinds of sources, from portals, databases, sensors, documents. There is nothing which we cannot use in today's world. So every kinds of data source is a candidate for us to analyze. We are going to ingest this by data flow, pipelines, event stream, content understanding into one lake. We are going to store it in one lake in a bronze, silver, gold medallion schema in some kind of increments. We're going to process this by notebooks, Sparks, MLflow, tracking, experiment logs. And afterwards, we are going to do some kind of intelligence. Either we're talking about typical knowledge mining by using notebooks, do some kind of experiments or whatever. Either we're talking about using natural language with data agent that we show last session by just simply chatting to our data. And everything here is completely traced by governance and covered by governance, from purview lineage, sensitivity labels, audit logs, everything. This is our end-to-end research data architecture, covered and everything under one hood. How are we going to map this to your research workflow? Data collection by this technology, data cleaning by Dataflow transformation, notebook validation scripts, analysis by notebooks, Spark, MLflow experiment tracking, document processing by content understanding, which I just show you, AI search, knowledge mining, collaboration with workspaces, one like shortcuts, share notebooks, publication with complete lineage from raw source all the way to published figure. Everything can be then used as some kind of final result. And not to forget, compliance with purview, sensitivity labels, DMP, data management protection mapping, audit logs for ethic boards or auditors or whoever. Let us just remind ourselves again on security architecture. Said 2 days ago that we are talking about onion layered security, where we have from network control and security workspace items, data security access control, where everything is around our data in a fabric, where we are doing completely auditing for every single step, accessing movement of data, changing of data, analysis of data, everything. And we can even set it up data security by granular access controls, applying row level security, column level security, dynamic data masking for certain groups of the users, if we don't want the users to see some kind of data that is not for them. For instance, for research, mask patient identifiers by allowing aggregate for statistical analysis. We don't need to know who the patient is. We just need to know some kind of other data that will be used in a statistical analysis. All this can be set it up and tracked from the administration perspective by administration tools. We haven't spent much time talking about it because it's irrelevant for our scope here, but just to mention here for your understanding that all this administration on a fabric can be used through the portal, through the PowerShell, through some kind of SDKs and APIs, admin monitoring workspace. And it's important here to mention, since we are in an AI world, that MCP servers for administration has been released officially as well here. So you can use AI agents like Claude or whatever you're using for administration of the fabric as well with the natural language. And from the administration perspective, obviously you want to check capacity usage, how many computes are being used here. Remember that everything that we are doing requires some kind of compute power. CPUs, memories, disks, GPUs, everything about around this, and you can track it in a detail and here. So moving forward to wrapping up what we demonstrated today, we had 3D demonstrations, data flow generation, and some kind of pipelines. We saw how to, on a dummy example, consume data from blob storage to our lakehouse with no code required, full pipeline, audit trail that replaces manual download, clean upload. On a second demo with the notebooks, we showed how to bring up the Apache Spark cluster in a background, put some kind of data in it, and train models automatically. After that, compare the results of it, do some kind of side-by-side comparison. And the last demo, how to leverage this AI moment, this time from the perspective of the content understanding, how to leverage the multiple models in understanding of the PDF structure field from research PDFs, understand confidence scores per extraction, scalable to thousands of documents. So that's definitely one thing that can even more enrich our data ingestion pipelines. Outcomes is to build, describe research data ingestion by those technologies, explain how to use MLflow. You are aware now of this technology as well. Content understanding, mentioning that you as well can use real-time data ingestion, IoT world, sensor data, sensor-based monitoring research, and wrap it all in an end-to-end architecture for research data workflow out of your domain. Like on the end of the session 1, I will give you as well a few links here from where to move on right now. Idea is not just to stop here on this session. Idea is that you guys start to play around with this technology and see how you can benefit from it. There is Azure for Research. It gives us free credits for approved academic projects. I believe this is beneficial for you. You can use Fabric free trial, 60 days full capacity to play around with it. You have multiple different kinds of learning content online available to dig deeper in this, because we spent only 4 hours to overview this technology and map it to some kind of processes and concepts that can serve you. And there are hands-on exercises for all topics covering all sessions on a GitHub, so you can try to do it by your own for a start. 2 sessions, complete picture. Session 1, answer to the question why, reproducibility crisis and founder mandates Fabric as some kind of research infrastructure, Lakehouse, medallion architecture, AI-assisted queries, governance, and session 2 gave us answer how. So ingestion, analysis, unstructured data handling, real-time data handling with security governance and administration. Once again, giving you here the news from the latest conference about the Fabric, that this is, in summary, that this is the fastest growing data platform in Microsoft history. I mentioned the MCP server right now that gives you opportunity to administrate the stuff around the Fabric, even to play around with the creation of the pipelines, flows, or whatever. Data agents are expanding. One lake can read multiple different kinds of other data sources, etc., etc., etc. This just means that this thing is evolving, and more news are yet to become here. Okay, so before giving some kind of you opportunity to ask me questions if there are some, my final honest note is that technology does not fix reproducibility. Culture does. Infrastructure makes great path for us. That has been said and talked with Carl before our session. Idea is that infrastructure itself is self-manageable and gives us opportunity to be as much as possible efficient in a work that is our focus, and that is research. And the great platform just give us opportunity not to think about infrastructure, not to think about auditing, not to think about all those stuff that are necessary in all these data lineage environments and all these processes, and we can focus on what is matter. And this is, I believe, what was shown in those two sessions. So before closing and saying goodbye, my last question to you guys, do you have any kind of questions, remarks?
Well, thank you very much, Mario. That's been really, really exciting. I know that it's been a long 2 days, 2 hour long sessions is quite a lot, but there's been a huge amount to cover there. And one of the key takeaways from this for me is that we can get overwhelmed by the actual size and complexity of the data, and having tools to be able to analyze that data is absolutely crucial. And so these are, could be amazingly valuable tools for so many people, not just in the natural sciences, but I was just thinking indeed of my daughter, who's actually a historian, looking at thousands and thousands and thousands of documents, and all from different data sources and everywhere else, and being able to analyze those and actually work out what's going on in those documents from multiple different sources in multiple different formats is going to be incredibly valuable. So really, really useful things to say. So thank you so much for your time, and yeah, great. Any other questions from anybody here on the call?
Hi, I have a practical question. I didn't get the chance to be there the other day, but will the recordings be on the Jean page, or where can I find them later?
Yes, Carlo, they will be available. We are just going to put the two together into one thing, and then we're going to do a little bit of a brief summary document so that hopefully we'll be able to share them with as many people as possible. And I think this is a really important field, and it's worth sharing. So yeah, absolutely.
Thank you.
Great. Well, thank you, everybody. Thank you very much for attending these two sessions. Thank you very much, Mario. And thank you, Microsoft, for funding these and arranging them, which was most appreciated. What I will do is, as I say, I'll produce the videos, and we'll have those shared. So basically watch this space. I'll be sharing them through the attendee lists of the webinars. So if you're a registered attendee, then you'll be getting a link to the videos once they're trimmed up and tidied up and basically sorted out. But thank you very much indeed, everybody. And have a great day, and have a great rest of the week, and a great weekend coming up. So thank you all.
Thank you guys for attention, and